Hello everyone. So in this video we will discuss about design of reinforced concrete elements. So short form we will mention as a DRC elements. Okay. So before going to DRC we have to know about what is meant by PCC. So PCC அப்படிங்கிறது வந்து பார்த்தீங்கன்னா plain cement concrete. So what is that plain cement concrete is nothing but the combination of cement, fine aggregate, coarse aggregate plus water. So this is plain cement concrete, whereas reinforced cement concrete means in addition to that we inserted the reinforcement. So along with we will call it as a PCC. So PCC plus reinforcement. So that we call it as a RCC, reinforced cement concrete. So what is mean by elements? So in the building means, so elements is nothing but the small structural elements which is the components in the building. So first of all this is the slab or floor, then this one is the beam, then this is the vertical member column we mentioned as a column, then finally the foundation. Below the ground level we construct the foundation. So these are the elements. So in the DRC we are going to design about these are the structural elements: slab, beam, column, foundation or footing. So then next, what is mean by how the load is distributed on the building. So first of all we have to design the slab, the load transfer from the slab to the beam, then after that beam load is transferred to the column, then finally the column load is transferred to the foundation, then foundation, from the foundation the load is distributed to the ground, that is the soil. If safe bearing capacity is withstand the overall load, based upon the soil conditions capacity only we are going to predict we will identify or we will discuss about then which type of foundation we will prefer. Like that we will discuss in the load distribution like that. So what are the bar diameter available in the market? So these are the we mentioned in the mm, that is 6 mm, 8 mm, 10 mm, then 12 mm, then 16 mm, 20 mm, 25 mm, 28 mm, 32 mm. So these are the mm available in the market. So nowadays we are using from the 8 mm only. So olden days we were used 6 mm, but nowadays we are using minimum 8 mm for reinforcement in the building. Next we will discuss about what is mean by mix ratio. So next, mix ratio. So mix ratio, in that we will discuss about we will calculate the proportion for the quantity of materials for the making of concrete, that is cement, fine aggregate, coarse aggregate. How much proportion we have to take for a concrete mix. So for that, so here we mention as a m. M is nothing but the mix proportion, whereas the number denoted as 5, 7.5, 10, 15, 20, 25, these are the numbers we call it as a characteristic compressive strength. After taking 28 days, we curing the concrete about 7 days, 14 days, 21 days, 28 days, like that. So after 28 days we are taking a compressive strength by using UTM, universal testing machine. So at that time we will get the strength of the concrete. That strength we will having a 5 Newton per mm square. So like that m 7.5 is 7.5 Newton per mm square. So we mention as a FCK, characteristic compressive strength, which will be denoted in Newton per mm square or megapascal. 1 megapascal which is equal to 1 Newton per mm square. So like that, if you are taking a M5 grade of concrete which is having a strength of 5 Newton per mm square or 5 megapascal. So here for the mixed proportion of M5 we have easily remember it: 1 portion of cement, 5 portion of fine aggregate, 10 portion of coarse aggregate. So 1 portion of cement, 5 portion of fine aggregate, 10 portion of coarse aggregate. So similarly, we always considering, we take it as a proportion for cement, we take it as a 1 only. 1 part of cement, 1 part of cement, 1 part of cement. So we can easily remember it. We will reduce 1 by 1 for M7.5, which is 4 part of fine aggregate, M10 3 part of fine aggregate, M15 2 part of fine aggregate, M20 1.5 part of fine aggregate, M25 1 part of fine aggregate. So similarly, twice the times of fine aggregate, we can easily remember it. Here 4, so into 2, 8. That is 8 part of coarse aggregate. Here 6 part of coarse aggregate. Here 4 part of coarse aggregate. Then similarly here 3 part of coarse aggregate. Here 2 part of coarse aggregate. So easily we can remember it. Keep it in mind. M5 is 1:5:10. M7.5 1:4:8. M10 1:3:6. M15 1:2:4. M20 1:1.5:3. M25 1:1:2. Remaining grade of concrete mix proportion, we will design the mix. So whatever it is a standard mix. So for that, next we will discuss about what are the different types of concrete grade. So here we can mention as a ordinary concrete, standard concrete, high strength concrete. So why we are segregated as depends upon the value or strength basis. We are categorized as these are the 3. So here ordinary concrete we will mention as a M10 and M15. We consider as a ordinary concrete. We can even we can use as a simple work. For that we will go for a ordinary concrete. Whereas go for a standard concrete, which is covered from M20, M25, M30, M35, M40, M45, M50, M55. These are the grade which is used for, we consider as a standard concrete grade. Whereas if you are using for high strength concrete, we always prefer for M60, M65. So these are the concrete grade. We categorize as ordinary concrete M10, M15, standard concrete from the M20 to M55, high strength concrete M60 to M65. Next we will discuss about the mechanism of concrete. So we will consider PCC and RCC. We already mentioned that PCC is combination of cement, fine aggregate, coarse aggregate, whereas RCC in addition of reinforcement we call it as a RCC. We have to know about always concrete is strong in compression. So how much load of we are giving on the concrete, it can be withstand. So it will be, failure will be very long. So it is strong in compression. When it comes to the tension, when we are giving the load on the concrete in the tension part, so this is the compression part, this is the tension part. So when coming to the tension zone, it is always weak. When giving on the load, on the concrete like that, so load is acting on the concrete, the compressed zone will be strong, so it is never failure. Whereas comes to the tension, it will be deflect like that. So when comes to the deflect like that, in the tension part will be leads to the crack. So for that only we are going insert the steel bar on the tension zone to overcome the failure of the concrete. That's why the RCC mechanism has been arised. So that's why we are going for a RCC. So we have to keep it in mind. So PCC is brittle in nature. When we are see on the high, it will looks very strong, but when we are giving on the load, it will be collapsed. When after inserting the reinforcement into the concrete, it will becomes ductile. Ductile means durability, lifelong. So that's why most of the marketing ad they are mentioning as a D. That D is durable or ductility. So we have to keep it in mind. Concrete is strong in compression, weak in tension. See? So this is the mechanism of RCC, reinforced cement concrete. So what are the different types of reinforcement available or where we were used in the concrete? So RCC, that is mild steel. So mild steel is nothing but in olden days they we used as a simply without any ribs. So this we call it as a ribs. So without ribs they are using this steel, we call it as a mild steel. In technical term we will mention as a Fe 250. So here 250, the number is mentioned as tensile stress Fy, that is 250 Newton per mm square. So Fe is ferrous, the technical term for the iron. So Fe 250 is 250 Newton per mm square. That much of tensile load can withstand by the mild steel. So after that they introduced the medium tensile steel, which is greater than the Fe 250. After that, nowadays we are most of the cases we are using for HYSD bars. So HYSD bars is nothing but high yield strength deformed bars. So in that we were used Fe 4 and 5. So 4 and 5 here nothing but the tensile stress 415 Newton per mm square. Then HYSD bars available is Fe 500, Fe 550. So nowadays we are using Fe 550D also. So D is nothing but the ductility, durability, like that we can easily say. So after that, thermomechanically treated bars, TMT bars. So thermomechanically treated bars we simply mentioned as a TMT bars. So these are the bars, these are the reinforcement we are using for the RCC. So next for that we have to know about the how much the cover have to be introduced for the different elements. So this is the RCC up to from the top of the surface of the concrete up to half of the reinforcement we call it as a FD, effective depth. So D is nothing but effective depth, whereas from the half of the reinforcement to the bottom of the concrete we call it as a D dash. D dash is nothing but effective cover, whereas clear cover nothing but the bottom of the reinforcement from here to up to here we call it as a clear cover. So we call it as a some technical term we can easily mention clear cover. So what is the value we have to provide for the different element of clear cover is nothing but the if slab, for the slab clear cover we have to mention as 20 mm. Minimum have to be provided 20 mm for clear cover, that is the distance of this much. This is the clear cover. So this clear cover have to be introduced for the slab is 20 mm. Whereas beam for the beam is we have to provide at the 25 mm. Beam means 25 mm. Whereas come to the column, minimum have to be provided at the 40 mm. So column means 40 mm. When comes to the footing, we have to provide the 50 mm. Yeah. So slab is 20 mm, beam is 25 mm, column is 40 mm, footing is 50 mm. So in any conditions, the clear cover should not greater than the 75 mm. So a severe exposure of the corrosion, we have to never more than provided the clear cover is 75 mm. It should maintain minimum of 75 mm. At least we have to requirement of 20 mm for the slab, 25 mm of the beam, 40 mm for the column, 50 mm for the footing. It should not greater than the 75 mm. What are the loads we will consider while designing the elements on the building, such that different types of loads, dead load. So self weight of the elements, that is a beam, slab, column, footing. So these are the elements we have that is having a some self weight is there. That weight we call it as a dead load. So simply we mentioned as a DL. Then live load. So ourselves, human beings, that utilize of over the dead load, we call it as a live load. So some of the live load example we will discuss. Then wind load, this is the wind zone where the maximum wind will be available. That area we will consider the wind zone, the wind load. Then some of the part will be experienced earthquake also. Seismic zone we consider as a seismic zone based upon the nature of the terrain. We will consider the seismic zone. So in that seismic zone also we will consider the earthquake load, that is EL. So some part of the country, the buildings exposed on the snow which will be covered, that is also that some part of load will be acting on it. So that load we call as a snow load, that is we mentioned as a ESL. So these are the load which will be acting on the buildings, so or elements we will take it as a. So what are the different combinations while considering the design of elements is such that, so these are the first combination is dead load plus live load. So only which will acting on the elements. Other combination dead load plus live load plus wind load, or some other cases dead load plus live load plus earthquake load, or some other cases dead load plus live load plus snow load also acting on the elements. So these are the load combinations. Next we will, what are the methods we are using for the design of the elements, concrete elements, nothing but the these are the three major methods we are using for the design of the elements. So number one is working stress method or elastic theory. So second one is the limit state method, then ultimate load method. So these are the three methods we are using for the design of elements. So this working stress method especially for the where the load is never changed in the life period. So water tank we will consider the water tank design, we are applying the working stress method. Nowadays we always design by using the limit state method. This is the economical one. So this method only we are going to discuss in the furthermore topics. Then finally ultimate load method, this is the uneconomical one. We are considering the major load, which is we are always considering for the maximum load. So that load will be, we are designing for the element which will be gives the uneconomical. So it is cost wise which is very large. So that's why we always prefer for the limit state method. So what are the standard codes which is used for the design of elements is nothing but the, so IS 456 2000 we are using for the design of 2000 IS 456. This is number one. We always used for the design of the RCC concrete. So next one IS 815. So this code having a part 1, part 2, part 3, part 4 like that. So each part which is we are taking the load for dead load, live load, wind load, earthquake load and snow load. So similarly we having a part 1, part 2, part 3, part 4 for the IS 815. So then special publication SP16 of IS 456. Some solved problems or standardized problems which is available in the SP16. So these are the major standard codes we are using for the design of the elements. So this is the explanation for the loads. What are the different types of loads? What are the different combination we will acting on the elements? Then what are the different methods we are going to use in the design of RCC? Then what are the standard codes we are using for the RCC elements?